say if I said 1/3 plus 1/2, can you just add that and say it's 2/5?
No.
No. What do you have to add fractions? Same denominator, common denominator. That's the bottom of the fraction. So what we usually had to do was multiply by something to make those denominators match. So what would I need to take the first one times? 2. And if you do it on the bottom, you have to do it on the top, right? And what does this one need? 3. So we turn this into 2/6 plus 3/6. Now when you add these together, does the bottom change? No. So the final answer is 5/6. So we can use this same technique to add rational functions. So things that have variables in them, not just nice numbers. Let's start with this one. The directions on these, it'll say simplify. I'll always just tell you to leave it in factored form, so I'm not going to make you multiply out your answer. So we have 2x squared minus 4 over 2x plus 5 plus x plus 3 over 2x plus 5. Out to the side, I have x cannot equal 5 over 2. What does that come? What is that? That's the domain. Very good. We talked about that Friday. That's just saying we talked about, ooh, there's a mistake. What was that? Negative 5 over 2. Sorry about that. It's telling me what number I can't have on the bottom, because the bottom can't be a 0. Does it have any impact on how we add or subtract? No. So a lot of times on the Math Excel, they're going to give you extra information like that. They'll have the domain. Don't let it confuse you. You're still just adding these fractions. To add, I need a common denominator. What do you notice? It's already the same. So I'm just going to jump right into adding. When I put these together, the denominator does not change. So it's still 2x plus 5. So we are just adding these numerators together. Add our like terms. So we have a 2x squared plus an x. Negative 4 and positive 3 is negative 1. It doesn't matter what order you write those terms in. So if you had an x plus 2x squared or something, I don't care. You just have to have those terms. Let's look at this one. H over 5p plus 3 over 4p. Okay, so we don't have a common denominator here. We need a common denominator. Looking at this, both of these denominators already have the p. So I really just have to work on getting those numbers to match. What could I multiply the first one by? 4. Do it on top and bottom. And the second one needs 5 on top and bottom. So I get 32 over 20p plus 15 over 20p. So now we can add them together. 32 plus 15, 47 over 20p. What if at that point I had like 40 over 20p? What would I need to do? Reduce. So always double check and see if that can be broken down. If there are any like terms there, but nothing cancels out, so we are done. So far, so good? times. Do I have a common denominator? No. What do you notice about these two denominators though? They're just opposites of each other. So what do I have to do to get that common denominator? Yeah. Does it matter which one? No. So I'm just going to multiply one of these by a negative 1. So maybe I do the second. So I have the first one I didn't change. 5 times negative 1 is a negative 5. On the bottom, if I'm going to multiply that by a negative 1, I have to distribute it to both, so it becomes a positive x and a negative 3. Is that one okay? So now if I put these together, are 2x and negative 5 like terms? No. So we just have 2x minus 5 or plus negative 5 over the x minus 3. Okay. Let's do this part. X over x plus 1 plus 2x minus 2 over x minus 1. I don't have a common denominator. Can I just multiply this one by a negative 1 and get the common denominator? They're close. Positive 1 and negative 1, they're just off by a negative. But if I multiply this by negative 1, it becomes a negative x plus 1. Is that what I need? No. So in order for the negative 1 trick to work, they have to be exact opposites. Both terms have to be the opposite sign. Okay, so what we're going to do, I'm going to recopy this and give myself a little more room. So the first denominator is an x plus 1. I need to treat that as one thing. Second denominator is an x minus 1. So if I want to make these the same, what does the first one need so it looks like the next one? Yeah, we need to get that x minus 1, so I'm just going to multiply by the whole thing. I'm just going to take this one times an x minus 1 on top and bottom. Okay, the second one already has x minus 1, but to look like the first one, it needs an x plus 1. Okay, so you can't just multiply by a minus 1 or positive 1. We have to do the whole thing. X plus 1 or x minus 1. So then, on the top, let's go ahead and distribute that. X times x gives me an x squared. X times negative 1 is a negative x. The bottom, you can FOIL those, but you do not have to, so I will just write them side by side. Okay, for here, if I start FOILing, we get 2x squared plus 2x 2x minus 2. At this point, these denominators do match. So we can make our one fraction. Let me just go through and add like terms. So 1x squared and 2x squared is 3x squared. Negative 1x, positive 2x, and negative 2x. Just a negative 1x. And then we have this minus 2. Is that one okay? So a little more to that one where we had to multiply by the entire parenthesis. But same idea, we're getting that common denominator. Let's look at this one. What's that? X cannot equal negative 2, negative 1, and 1. It's just the domain. Does it change our answer at all?
No.
Alright, so we are just going to ignore that. We don't want to make our problem any harder than it has to be. So I don't necessarily want to multiply by an x squared minus 1 and the x squared plus 3x plus 2. Remember when we were multiplying and dividing? Sometimes we factored things first to make our problem a lot easier. Let's start there. So sometimes on this, you might want to factor your denominators before you get the common denominator. So in other words, I'm going to leave this as an x. We can do a box method down here. Shortcut because of the 1x squared. What multiplies to 2 and adds to 3? 2. I'm not concerned with the numerators. I'm not trying to factor those at all. X squared minus 1, what would I write for that?
X plus 1, x minus 1.
So now, let's get that common denominator. The first parenthesis has an x plus 2 and an x plus 1. What does the second one have that this one doesn't? The x minus 1. You all see that? So that is the new piece this first fraction needs. So I am going to multiply x minus 1 on the top and bottom. Trying to make them identical. The second one had an x minus 1, so it needs it. If I'm looking at the second one, it has an x plus 1 and an x minus 1. What do we have in the first that I need? An x plus 2. Does everyone see where I got that? Do I need me to go over that part again? Both of them had that x plus 1, so we didn't have to include that anymore. So now if I'm looking at what I have left, multiply the top, distribute that x, so we get x squared minus x. On the bottom, I don't want to multiply this out, I'm just writing all three of them. We have an x plus 2, an x plus 1, and an x minus 1. Plus, second one. My denominators match. If I FOIL on the top, we get a 2x squared plus 4x minus 3x minus 6. Once those denominators match, we can make one big fraction. So if I add like terms, 1x squared and 2x squared will give me a 3x squared. Negative 1x plus 4x minus 3x. Those all canceled, don't they?
Yep.
And then we have that minus 6 left. We need some more of these. Where are we at here? Did you guys get to these in algebra 2? No? Don't remember them? Okay. Do we need another example?
Let's do one more.
One more? I like it. Why don't you guys try it on your own, and let's see how far we get. So, how about... Let's go with two over y squared minus 7y plus 12 minus 3 over y squared minus 16. On the right track. It looked like everybody was doing the first step. You all started out factoring, which is good. Y squared minus 7y plus 12, that's box method. Multiply to positive 12 and add to negative 7. Okay. Y squared minus 16, how do we break that up? Difference of squares, good. Okay, what does the first one need to look like the second? The second one has a y plus 4, so we need that. And what does the second one need? So then, if I distribute by 2, we get 2y plus 8 over y minus 3, y minus 4, and y plus 4. It does not matter what order you write those parentheses in. You just have to have them. This one, that becomes a 3y minus 9. Alright, slightly different. I think all of our other examples we were adding. If there's a subtraction here, what should I do with that? Yeah. Well, distribute that negative, so we have a negative 3y and a positive 9. So if you're subtracting those fractions, just change it to a positive and run a negative through the second one. So then we can put them together. 2y and negative 3y is a negative 1y. 8 plus 9 is 17. Over y minus 3, y minus 4, y minus 4. Can I do one last example? It's a very short one, I promise. I think there's one like this on the Math Excel. It has a fraction within a fraction like this, and it just tells you to simplify it. Okay. Periodically, I like to show you guys little tricks that can make really complicated problems easier. So sometimes we might encounter something like this, and it looks really ugly, but there is actually a very simple way to clean this up. When you have a fraction, we know it's legal to multiply something as long as you do it to both the top and the bottom, right? The part that makes this so ugly is that we have this over x on both of them. If you wanted to cancel that denominator, you would just have to multiply by x, correct? So what I'm going to do is take the top and bottom of this fraction and just multiply it by an x. That's legal. We did it on top and bottom. So on the top, if we distribute, 3 times x would be a 3x. Plus, what's 2 divided by x times x? 2. On the bottom, 3 times x is 3x. Minus 1 divided by x times x. And you are done. Okay, so a quick way to clean up a problem like that is just multiply by whatever's in the bottom. Since now we have more than one term because of the addition and subtraction, we can't. But if it was like this, so multiplied so it's all one term, then you would cancel your 3's. Other questions? Okay. So, on Friday we had that R.4 Math Excel. You have the rest of the hour to work on that assignment and finish that up. If you've looked at the board, we're going to have a quiz on Wednesday over all the stuff we've been doing. So tomorrow we are just having a review day. Okay, so tomorrow I'm not teaching anything.